Imagine this. It's the summer of 1910. The sea is calm. The sun low, and a small wooden boat drifts alone on the Gulf of Genoa. Inside, it stands a man in a worn brown suit. Sleeves rolled to his elbows, sweat glistening on his temples as he leans over a strange metallic box. A wire runs from the device into the dark water below. The man isn't fishing, and this isn't a scientific expedition backed by a university or a grand observatory. It's just one man, chasing invisible ghosts. A man about to uncover proof that the heavens themselves rain energy upon the earth. His name was Domenico Pacini, and you've probably never heard of him. Before we dive in, tell me something. Where are you watching from, and what time is it there right now? Drop it in the comments. I love seeing our little community of curious minds light up across the globe. And while you're at it, hit the like button, share this video with someone who loves hidden history. And subscribe, because here we bring back the names the world forgot. The year is 1910, and science is still intoxicated by its own discoveries. X-rays, radioactivity, electrons, invisible worlds had been unveiled just a decade earlier. Names like Marie Curie, Ernest Rutherford, and Henri Becquerel are already carving their legacies into the story of modern physics. Yet in the midst of this golden age, a quiet Italian physicist is working in near solitude, driven by something more dangerous than ambition: doubt. At the dawn of the 20th century, scientists were obsessed with radiation. They believed that the mysterious electric charges in the air, the ones that made their instruments tick and hum, came entirely from the Earth's crust, from radioactive minerals seeping energy into the atmosphere. It was an elegant explanation, simple and safe. But Pacini wasn't convinced. He didn't see the world as a closed system. Something he felt didn't add up. Pacini was born in 1878 in Marino, a small town near Rome. His life began humbly, without the wealth or connections that could open academic doors. Italy, at that time, was not the powerhouse of science that France or Germany were. Research funding was scarce. Equipment was outdated. But Pacini's curiosity burned brighter than the limitations around him. He joined the Central Bureau of Meteorology and Geodynamics, a modest institution where he worked as an assistant studying the Earth's magnetic field, electric currents, and atmospheric radiation. It wasn't glamorous work. He spent his days measuring faint, invisible phenomena, the kind of science that demanded patience, faith, and obsession. Still, he was restless. While others looked to the ground for answers, Pacini looked to the sky. His instruments, delicate electroscopes designed to measure ionizing radiation, were supposed to confirm that the Earth was the source. Yet every reading told a different story. The numbers shifted unpredictably, changing with the weather, the altitude, even the time of day. It was as if some unseen hand beyond the planet was touching his instruments. He started to wonder, what if the energy wasn't coming from below, but from above? What if space itself, the great silent void, was raining radiation onto Earth? It was a radical thought, to his colleagues, even heretical. Why question what everyone had already accepted as truth? Pacini didn't argue with them. He decided to prove it instead. With little funding, he began designing experiments no one else dared to attempt. In the laboratory, he built his own electroscopes from scratch: glass chambers, thin gold leaves, and metal plates. He tested them in open fields, in tunnels, and on mountain slopes. The results whispered the same secret. The intensity of radiation didn't behave as it should if it were coming solely from the Earth. Sometimes it seemed stronger in the open air than near the ground. Sometimes the readings dropped when surrounded by dense rock. Something beyond the surface was clearly at play. But Pacini knew that to convince the scientific world, he needed irrefutable evidence. The only way to prove his theory was to measure radiation in an environment shielded from the Earth and the sky, a place where one could isolate the source. That's how he came up with his most daring idea. He would take his instruments to sea, and then under the water. Picture it, the Gulf of Genoa. Early morning. The sea ripples quietly. Pacini sits in a small military boat, an electroscope placed carefully inside a watertight copper box. He lowers it slowly, meter by meter, into the deep blue. He's nervous. One mistake, and the instrument will flood. The water closes over the box like a curtain. He waits. Minutes pass. Then he lifts it back up, takes a reading, and the result makes his heart race. The ionization level had dropped significantly underwater. The implication was monumental. If the radiation were coming from the Earth, being submerged should make no difference. But if it came from above, the water would absorb or block it, exactly what he observed. In that quiet moment on the open sea, Domenico Pacini realized he was standing on the edge of something far greater than anyone imagined. The radiation filling our air, our oceans, our very bodies, wasn't just terrestrial. It came from the cosmos. But there was no fanfare, no applause, no flashing cameras. Only the sea breeze and the sound of waves against wood. He took careful notes, repeated the experiment multiple times in different locations. Lakes, coastal waters, and rivers, and each time the pattern held true. The invisible energy raining from the heavens was real. He published his results in 1911 in the Nuovo Cemento, an Italian journal. The title was modest, Penetrating Radiation at the Surface of and in Water. The content was anything but. In those fragile pages, Pacini quietly rewrote humanity's understanding of the universe. Yet few would ever read it. The scientific world spoke English, German, and French. Italian, rarely. His work was buried under language barriers and limited distribution. He had discovered cosmic rays, but almost no one knew it. Pacini kept working, refining his methods, convinced that time would vindicate him. He wrote to colleagues, tried to gain attention from larger institutions, and sought collaboration with other researchers across Europe. But the silence he met was deafening. Italy's academic world was fragmented and without international recognition. His papers floated unnoticed in the tide of early 20th century science. Meanwhile, across the continent, another man was beginning his own journey toward the same truth, Victor Hess, an Austrian physicist preparing to take his instruments not under the sea, but high into the sky. The two men were strangers, yet their paths were destined to collide in the annals of history. Hess would rise in a balloon above the clouds to measure radiation levels, while Pacini, alone in his boat, would descend into the depths below. Both would find the same cosmic rain, but only one would be remembered. In that sense, Pacini's story is more than scientific. It's a portrait of human nature, how recognition often favors those with visibility, resources, and timing, not necessarily those with vision. As the sun dipped below the horizon and the waves turned to molten gold, Pacini packed his instruments, unaware that history would soon turn the page without him. He had seen the fingerprints of the universe in his data. He had touched something infinite, and yet he would spend the rest of his life in the shadows of those who came after him. But on that quiet evening, as the boat drifted gently toward the shore, Domenico Pacini smiled to himself. He didn't need the world to believe him yet. He had seen proof that the universe wasn't silent. It was singing in waves of invisible light, in particles traveling from stars to sea. The year was 1911, and Domenico Pacini's discovery was ready to shake the foundations of modern physics. Yet, as he carefully prepared his data and sealed his notes with trembling hands, the world outside remained indifferent. No journalists. No telegrams from universities. No rush of letters asking for collaboration. His findings, the first experimental proof that radiation came not only from the Earth, but from space, echoed into silence. But Pacini was not done. If anything, the silence only sharpened his resolve. He wanted more evidence, more precision. He wanted to understand how deep this cosmic influence ran. So, once again, he packed his electroscopes, his notebooks, and his willpower, and set out on another series of experiments. He tested in the Lake of Genoa, lowering his instruments into the still waters. The pattern repeated itself with elegant consistency. Radiation levels dropped underwater, proving again that part of the ionization came from above. Pacini meticulously documented everything, crafting his results like a craftsman polishing a sculpture. His data was clean, his conclusions cautious but confident. He wasn't guessing, he was measuring. But in an era before global collaboration, before email, before conferences could connect continents, a paper published in an Italian journal was like a message sealed in a bottle. The bottle might float for years or never be found at all. At the same time, hundreds of miles away in Austria, Victor Hess was asking similar questions. The Earth's crust theory was showing cracks. Some readings didn't match expectations. Radiation didn't weaken with distance from the ground, as it should have if it came solely from terrestrial sources. Hess, methodical and resourceful, decided to take his instruments where no one had gone before. Not down, but up. It's a striking contrast, isn't it? Pacini, alone on the sea, lowering his detector into dark water. Hess, rising through clouds, his balloon brushing the edge of the atmosphere. Two men chasing the same invisible truth from opposite directions. In 1912, Victor Hess ascended into the skies on a hot air balloon, carrying 3 electroscopes carefully shielded from the wind. He climbed higher and higher. 1 kilometer, 2, 3, 4. With each ascent, he noted something astonishing. The radiation levels increased with altitude. The further from the ground, the stronger the radiation. This was impossible if the radiation came only from the Earth's crust. The energy, therefore, had to be coming from space. When Hess landed safely after his 7th flight, his data confirmed what Pacini had already seen a year earlier, from the opposite end of the spectrum. Yet history would not remember them as equals. The scientific world was enthralled by Hess's achievement. The image of a man ascending through the heavens to measure invisible forces captured imaginations in a way Pacini's lonely underwater experiments never could. Newspapers printed stories of the man who measured radiation in the sky. Professors discussed his bravery. The Austrian Academy honored him. His name began to travel through scientific circles like an echo gathering momentum. Meanwhile, in Rome, Pacini watched as the world embraced the same discovery he had made without his name attached. Imagine the frustration. You dedicate years of your life to proving something unthinkable, performing painstaking measurements, only to see someone else celebrated for reaching the same conclusion because your voice was quieter, your language unfamiliar, your country scientifically isolated. He tried to speak up. Pacini wrote letters to colleagues and institutions. One letter to the Accademia dei Lincei made his position clear. It seems a bit unjust that credit is being given to Hess alone for results which I had already obtained. My experiments carried out at sea and underwater had already shown that the radiation could not be of terrestrial origin. His tone was not bitter, just wounded. He wasn't seeking fame. He was seeking fairness, but his protest barely left a ripple. The truth is, Hess had advantages Pacini could never have dreamed of: academic support, funding, international visibility, and a stage in the German-speaking scientific world, which dominated physics at the time. Pacini, on the other hand, worked with minimal resources and published in Italian, a language rarely read by leading physicists outside Italy. And then, as if fate itself wanted to test his endurance, the Great War broke out. Europe descended into chaos. Science, like everything else, became fragmented, nationalistic, and politically driven. Communication between countries collapsed. Research slowed or was redirected toward military needs. In that atmosphere, Pacini's voice vanished completely. He continued working quietly, stubbornly, recording atmospheric data, magnetic variations, and radiation levels. But his lab was underfunded, and his health was deteriorating. He had glimpsed something eternal, and yet was trapped in the mortal limits of recognition. What made his tragedy even more poetic was the nature of what he had discovered. Cosmic rays, high-energy particles from distant stars, supernova, even galaxies, are, in essence, messages from the universe. They travel across light years, across time itself, until they strike our planet, whispering stories of the cosmos. Pacini was the first to listen to that whisper from below the waves. And yet, when the history of cosmic rays was written, his name was nearly erased. In 1936, Victor Hess received the Nobel Prize in Physics for the discovery of cosmic rays. By then, Domenico Pacini had been dead for 2 years. He never saw the award, nor heard his name mentioned alongside it. But the truth, like cosmic rays themselves, cannot be buried forever. It passes through walls, through water, through generations. It reaches where it is meant to reach. Decades later, historians and physicists would stumble upon Pacini's papers, yellowed with age, buried in Italian archives. They would read his words and see the unmistakable data. The same pattern Hess had found, a year earlier, under the sea. Slowly, piece by piece, Pacini's name began to rise from the depths where it had been forgotten. But at this point in our story, around 1913, Pacini was still alive, still working, still hoping someone, somewhere, would notice. In one of his later notes, he wrote about his experiments with a tone of quiet pride, but also resignation. He had proven what he set out to prove. The rest, he seemed to accept, was out of his control. The world, he must have realized, often confuses discovery with publicity. And so, while Victor Hess soared into history, Domenico Pacini sank into silence. His instruments gathered dust. His reports faded into academic obscurity. His name was gradually left off citations, textbooks, and lectures. Yet his data never lied. His numbers, recorded by hand, measured in solitude, remain irrefutable. He had done it first. There's something hauntingly poetic about that. The man who proved that radiation rained down from the stars died without ever receiving his share of light. As the years passed, the glow of his discovery was swallowed by time, just as the sea had once swallowed his instruments. And still, above the waves, cosmic rays kept falling endlessly. As if the universe itself remembered the man who had dared to listen. Pacini's story is not over yet. His redemption will come decades later, when forgotten papers resurface, and scientists finally give him the credit he deserved. But at this point in our tale, he is still standing alone, his truth ignored, his legacy unspoken. He had touched the stars, and the world had looked away. By the time Domenico Pacini breathed his last in 1934, the world had already forgotten his name. There was no ceremony, no speech, no mention in the scientific press. His papers, the quiet handwritten pages that held the blueprint of his greatest discovery, were stored away in dusty drawers of Italian institutions, rarely opened, rarely cited. The sea that once reflected his triumph now seemed to have swallowed his memory whole. 2 years later, in 1936, Victor Hess stood before an applauding audience in Stockholm, Sweden, to accept the Nobel Prize in Physics. Dressed in black formal wear, Hess thanked his mentors, his collaborators, and the scientific community that had celebrated his daring balloon flights. He had earned it, certainly. His experiments were brilliant, his courage undeniable. Yet, somewhere in that applause, there was a silence so loud it could have split the air. The silence of the man who had gone into the water before Hess went into the sky. Pacini's widow, if she read the headlines, might have stared at the newspaper for a long time. No one would ever know what she thought. No one interviewed her. The Italian government didn't protest the omission. There were no petitions, no campaigns. The discovery of cosmic rays became a story of courage and flight, not solitude and stillness. The man in the boat was gone, replaced by the man in the balloon. And so, for nearly a century, that is how history told it. But truth has a strange way of resurfacing. Like light piercing through deep water, it bends, distorts, and eventually finds its path back to clarity. Decades later, in the early 2000s, a new generation of Italian physicists began digging through old records, tracing the roots of early radiation research. Among the faded ink and fragile paper, they found something extraordinary: Pacini's original experimental reports. His 1911 data, still precise, still consistent, still impossible to ignore. For the scientists reading those papers, it was like unearthing buried treasure. The graphs, the numbers, the careful comparisons between land, air, and underwater radiation, everything matched modern understanding of cosmic rays. His conclusions had been right all along. The evidence was undeniable. They began to speak his name again. At first, quietly, in conferences, in footnotes, then louder. In 2003, the Italian physicist Alessandro De Angelis published detailed research confirming Pacini's priority in discovering cosmic rays. He wrote, "Pacini should be credited as the discoverer of cosmic rays, alongside Hess. Their experiments were complementary. Hess went up, Pacini went under, both reaching the same conclusion from opposite directions." Those words struck the scientific community like a delayed thunderclap. For the first time in nearly 100 years, the narrative began to shift. Some historians proposed calling it the Hess-Pacini discovery, honoring both men equally. A few institutions in Italy even organized small exhibitions dedicated to Pacini's work, his forgotten instruments, and the humble labs where he had recorded his data. His name, once erased, began to shimmer faintly again, not in the headlines, but in the hearts of those who understood. It is poetic, isn't it? The man who discovered that the universe constantly rains invisible light upon us, himself becoming invisible, only to be rediscovered by that same light decades later. Today, cosmic rays are not just a curiosity. They are one of the cornerstones of astrophysics. They tell us about supernova explosions, black holes, and the birth of galaxies. They are the messengers of the cosmos, streams of high-energy particles crossing millions of light years to reach Earth. Every second, thousands of them pass through your body, through the sea, through mountains, through memory itself. And somewhere, in that endless shower of particles, perhaps there's a kind of cosmic justice, because each ray carries with it a fragment of Domenico Pacini's legacy. If he were alive today, perhaps he would smile quietly as he did that day on the Gulf of Genoa, lowering his instrument into the water. He would not ask for fame. He would not demand apologies. He would only point, as he always did, toward the mystery that still humbles humanity, that the universe, vast and silent, is speaking to us constantly, if only we have the patience to listen. History often forgets its quiet heroes, not because they lacked greatness, but because greatness doesn't always come with noise. Sometimes it comes in whispers, in the sound of a pencil scratching data on paper, in the creak of a small boat rocking in the waves, in the determination of one man to prove what the stars themselves already knew. So the next time you hear of cosmic rays, those tiny travelers from distant galaxies, remember Domenico Pacini. Remember the man who didn't rise to the sky, but sank into the sea to touch the truth first. And if you've made it this far, tell me something. Do you believe that forgotten geniuses ever truly disappear? Or does their work, like starlight, keep traveling long after they're gone? Drop your thoughts in the comments below. And if you want more untold stories of minds that changed the world but were never celebrated, make sure you like this video, share it with someone curious, and subscribe to Pioneers in the Dark, where we bring light to those who history left in shadow. Because in the end, even in darkness, there are always those who saw the stars first.